My name is Christian Schmutzer. I'm happy to see you watching my video, and I would like to explain you what the details are about PLE or private line emulation. In essence, private line emulation is a combination of two things. First of all, tackling the problem of bit transparency and the transport of non-Ethernet protocols. And second, we are combining that with a point-to-point construct called a pseudo-wire, which provides us a layer 2 VPN connection over an IP or MPLS network. You may wonder, why would you do that, right? Well, in the last couple of years, or maybe a decade, actually all the energy moved into making chipsets for routers and switches faster. And we're now at 10 terabits or 12 terabits, approaching 20 or 50 terabits per chipset. This is much faster than OTN or SONET, which are chipsets that we are using in TDM networks. And TDM networks so far have been used to carry private lines or those point-to-point bit transparent protocol independent services. Another thing actually happened is that we made it much easier to build networks, because now with all this innovation, we can provide routers and switches that provide 10 gigabit, 100 gigabit, 400 gigabit Ethernet interfaces in many different shapes and forms and cost and power envelopes, right? So basically you can pick and choose the product of your choice and you deploy it in your network, making basically IP and MPLS and packet switching available anywhere you want it. Now, if we look at private line emulation in more detail, we're actually taking something that is not new. The concept of emulation has been used, for many years, and that this started probably 10 to 15 years ago, standardized by the IETF. And we use that to carry SONET and SDH interfaces over an MPLS network. And we're basically building about on top of that foundation. But now we are carrying high-speed interfaces like 10 gigabit Ethernet, 100 gigabit Ethernet, 32 gig fiber channel, OTN interfaces, whatever you have. How we do that is essentially we're operating at the bit stream, and we're taking a stream of bits in on an ingress of the network, encapsulate it into packets, and send them across the network so that on the other side we can play them out on the egress far end PLE client port. We play them out exactly with the clock as we got the bits in on the ingress side. Now, how we do that is we're using a technology called differential clock recovery. And that differential clock recovery is recovering the clock. And the way it does that is basically on each and every packet, we're putting a timestamp. And the sequence of timestamps is giving us an indication of the clock of the bit stream. And we're comparing that with a common clock reference so that on the other side, the combination of the common clock reference and the RTP timestamps in the packets is giving us the indication of the clock we have to send the bits out. Now, this gives us essentially a bit transparent connection over a packet network. And this is basically the concept we have been working on and are standardizing it as well. But on top of that, what you need, or actually on the bottom, you need also a co-routed bi-directional packet transport, which is allowing us to basically send traffic in both directions along the same path in the network. And it also gives us the opportunity to commit bandwidth, make sure that the path is persistent and the way we want it. And also it gives us the opportunity to, for example, establish a working path, a protect path, and on demand, if needed, a restore path, if, for example, we have double or triple failures. How we do that in a segment routed based network is using circuit style segment routing. This concept, again, is being standardized in the IETF and is leveraging a centralized path computation element intelligence, so that essentially if the source and destination is asking, hey, can I have a co-routed bidirectional protected path? The path computation element is looking at the topology, looking at the bandwidth utilization, and is ensuring that the resources and the routing requirements are satisfied for our PLE pseudo-wire that we are establishing between the ingress and the egress node. As I mentioned twice, PLE and circuit style SR are being standardized in the IETF, and you can see here the links to the currently work in progress drafts. We are very happy with the progress, and we are hopeful that this will be standardized in the community and allows us to basically drive adoption of this technology and making sure that we have interoperable implementations further down the line. I want to finish up. Why would you actually do this on top of the fact that things have changed and the routers are faster and cheaper now? Well, if we look at what we're doing today, right? Routed optical networking, for example, is addressing the point that you run, in a lot of cases, IP or MPLS over OTN and then over DWDM. By removing the OTN layer, we basically simplify the network and drive cost out of the network. But we are still having the problem of how to deal with private lines. Now, there is one way to do that, is essentially to emulate SONET and SDH using existing circuit emulation implementations. And we're basically taking one set of private lines, the low-speed private lines, out of the equation. But then the high-speed circuits or high-speed services are still left, and how do we deal with them? Do we keep OTN infrastructure in place, right? Or is the alternative, and this is what we're really contemplating and proposing here, is that we're using a single IP MPLS infrastructure that carries IP native services, carries low-speed private lines using circuit emulation, or what we often call TDM to IP approach. And then third, we're actually using private line emulation to carry all the rest, the high capacity private line services as well. So now you have a single network using IP MPLS and underneath DWDM to scale the optical capacity. So with this approach, we actually now can carry all the private line services and we have a common network. Hopefully this video has given you a nice summary of, first of all, explaining you what private line emulation is. And the second important part is, why would you care about private line emulation and what is in for you? If you would like to have more information, please visit the Routed Optical Networking page on our Cisco.com page. And thank you very much for your time.